Okay, next is question number 17. Okay, in question number 17, it says a student is about to do a bungee jump from a high bridge. Okay, the student is attached to the bridge by an elastic rope. An elastic rope, that means it will extend as force will be applied. Okay, the student jumps from the bridge and initially accelerates. The diagrams show the student at three different positions during the bungee jump. Okay, so you can see a figure. It shows the following figure shows three position of the student. So at position A, the distance fallen by the student is equal to the original length of the rope. Okay, fine. At position B, the student is in equilibrium. Okay, and at last at position C, the rope has maximum extension. That means at position C, the rope has been extended to its maximum possible length. Okay, now the question in part A, it is asking to explain how the acceleration, okay, of the student changes as she moves from position A to position C. Assume that air resistance is negligible. Okay, so this is basically an asterisk type question. We call it as star marked question. So in this case, your explanation and your structure of your answer should be very clear and coherent and perfect. Okay, so the question is asking to explain that how the acceleration changes as the student passes from position A to position C, right? So to explain the acceleration, we have to consider the force, because acceleration it's dependent on the force. Okay, so at first consider position A. In position A, how is the acceleration? In position A, the weight of the student it's greater than that what? It's the weight is the resultant force, because the initially the rope has not been extended to its original length, right? It was slack, right? It was loose. The rope was loose. Okay, so that's why there were no tension in the rope initially. Okay, so initially the resultant force of the student on the student it is its weight. Okay, then what happens? Since the resultant force is downward, so the student will accelerate in the downward direction, so its speed increases and it reaches the original length. The original length, as it reaches the original length, it becomes now what? Tightened. The rope becomes tightened, and so tension becomes effective now. Okay, so what we will write at first, initially the resultant force, right? The resultant force acting on the student is weight. So the student accelerates in the what? Downward direction. Okay, downward direction. Okay, so the in position A, basically the student is what? Accelerating in the what? Downward direction. So the student accelerates in the downward direction in position what? A. Okay, fine. Next, after position A, the rope has been extended. The rope is now tightened, right? So tension is effective. So what we can say, between position A and B, tension force acts, right? So as tension force is acting on the student, so resultant force will be what? Weight minus the tension. So still it is accelerating in the downward direction. So as it accelerates in the downward direction, the rope extends. As the rope extends, the tension in the rope will be increasing. Why? Because we know that F, the force, it's proportional to what? extension. F is proportional to del X from the Hooke's law, right? So that's why as the after the rope has been tightened, after the rope has become taut, okay, as the student moves further downward, the rope extends. As the rope extends, tension in the rope increases because force is proportional to extension according to Hooke's law, and so tension will keep increasing. Therefore, what will happen? The resultant force will keep decreasing. The initial resultant force was in the downward direction, so this resultant force is now decreasing. Okay, so that's what we will write here. Between A and B, as the student accelerates in the downward direction, what happens? The rope extends. The rope extends, so the tension force in the rope increases. Therefore, what we can say? Therefore, the resultant force. Downward result. Okay, let's mention the direction. Downward resultant force. Resultant force decreases, and at position B, what happens? So the downward resultant force, it gradually decreases between A to B, and at position B, the tension of the rope is equal to the weight of the student. Okay, since the tension of the rope is equal to the weight of the student, so that's why resultant force is what? So resultant force is 0 Newton, hence no acceleration. That means it is in equilibrium, right? Okay, so we have described till position B how it is coming to equilibrium. Now what happens to B to C? Since the student reaches equilibrium position at position B, so after position B, what will happen? It will keep moving in the downward direction with constant speed, right? So between B and C position, okay, between B and C position, the student moves further downward, extending the rope further. So tension increases further because tension it's dependent on the extension of the rope, right? So tension increases. So at C, at last, what happens? At C position, tension in the rope is greater than tension in the rope is what? Greater than greater than weight of the student, right? So resultant force is upward, hence the student decelerates. That's it. Done. We have explained till position C how the acceleration of the student changes. That's what part A of question number 17 has asked for. Fine. Okay, next is part B of question number 17. So here the question says the bridge is above a river. The student will reach the river if the rope stretches to a total length of 35 meters during the bungee jump. Okay, that means the height from where the student is jumping off, it is at a height it is basically 35 meter, right? Because as the student falls by 35-meter height, it will reach the what, river. That means the height of the platform from where the student has jumped off, it is what, at a height of 35 meter from the river. Okay, next they said the student has a mass of 65 kg. The original length of the river is it's 17 meter. Okay, the rope behaves like a spring with stiffness constant 250 newton per meter. The value for k it's given here. So the question is to deduce whether the student will reach the river during the bungee jump. Okay, so we need to deduce here whether the student will reach the river or not. Okay, so at first consider uh, as the student falls by 35 meter, it reaches the ground. So definitely as it reaches the river, so as it reaches the river, how much potential energy the student will lost. Okay, so this is E GPE. This is the lost potential energy. This is what, mgh, 65 g times what, height is how much, 35. So this is basically 65 times 9.81 times 35. So that would give you 22,317.75, that much joule. Okay, that much energy, potential energy the student will lose as it reaches the river. Okay, so now we know that what is the scenario here, like how the energy is getting transferred in this case. Here potential energy will get transferred to elastic strain energy of the rope as the rope extends, right? So let's find out, like, to have this amount of elastic strain energy, how much how much the rope has to extend. Okay, so what we will consider, so half of the formula for elastic strain energy, which is what, half of F del x, but we will use here K del x squared because we know the value for K. So half of K times del x squared, it is equals to how much, the lost gravitational potential energy of the student. Okay, so from there let's find out the value for del x. So 22,317.75 times 2 divide 250. So this is 178.542. So the value for del x would be square root of answer. That would give you 13.3619609.3, that much meter. So if the rope extends by this amount of length, okay, by this amount of length, then there is what, 22,317.75 joule. That amount of energy will get stored as elastic strain energy within the extended rope. So total length would be how much, original length is 17, so 17 plus 13.36 something, so this will give what, 30.365. Okay, so this is 30.36 dot 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 that much meter, which is basically less than 35 meter. So that means what we could deduce from here, the student will not reach the river. Hence, the student will not reach the river during the jump. Okay, that's the deduction. That's it. Done. And that's the end of question number 17 from the October 2024 Physics Unit 1 paper. Fine.